Um, we're kind of going over number 5 on the preparation activity.
So how would you write the answer, Callum? Would it be 3 pi over 2, or would you write just like the coordinate 0, -1?
Hold on. On here, it doesn't really have like write the answer, what it is, just has us plot it. But,
Okay.
Okay. Plot the following polar coordinates. That one?
Yeah. Yep.
I only got one of the homework assignments done, so polar coordinates means nothing to me.
Yeah, I just looked at the answer and was like, oh, that makes sense, and that taught me how to do it. Can't work backwards on it.
Okay, cool.
All right. So how do you find polar coordinates? Or
Okay.
what are those
So,
coordinates?
in the instruction right there, it says if the radius is negative, the radius is the x-axis, is the x coordinate.
Okay.
So if the radius is negative, then you go clockwise.
Okay.
So that's why it's plotted on the point. How do you what?
So the rate.
Yeah.
So 2 over, and then it goes clockwise.
So since it's not negative, since it's positive, it'll go counterclockwise. So you go over 2, and then you go counterclockwise 150 degrees and the plot point there. But you draw the full circle, and then you just plot a point on the circle where it's at.
Oh, you draw a whole circle.
Then you just plot the point on the circle.
Okay.
And then the second one, so you go -3, you go back 3, and where it's just pi, that means you just go 180 degrees. I mean, you're supposed to go counterclockwise, but it's the same if you go clockwise. So it just gets plotted on 3 with 0.30. And then you just draw a circle. Or 0, 3. Sorry. 30, yeah.
30 and pi 3 is it? Oh, yeah. Okay, so -30 and 30.
No, sorry, I said it wrong. So it's just plotted on the circle. It's just on the x-axis on the point 30.
Just 30?
Yeah, so you start on -3, and you go around pi, which is 180 degrees, and that ends you on the point 30.
So do you plot the first point? Like on the first one, don't you plot 20?
You don't have to. That's just kind of where you start.
Oh, okay.
And you go however many degrees from that point. That's just kind of your radius.
Gotcha. Okay.
The third one, you have a radius of 1, and then it's -pi/2, so you go clockwise 90 degrees. Right? Is that 90 degrees? Yeah. So it gives you, that's the exact same point
0,
as
-1.
the fourth one. The third, 3 and 4 have the exact same point.
3 and 4?
Yeah, they're on the exact same point. Does that make sense? So number 3, you start on +1 on the x-axis, and you go clockwise 90 degrees. And then on number 4, you start on the -1, and you go clockwise 450 degrees.
Then you go counterclockwise 450 degrees?
And this, since you have it gives you a negative radius, then you go clockwise.
Wouldn't it be, if you go clockwise, wouldn't it be 0, 1, not 0, -1?
Go clockwise. I'm sorry. I go in the wrong direction. Yeah, I was going the wrong direction. It is counterclockwise.
So you go counterclockwise.
Yeah, that's my bad.
That's what I thought. Okay, cool. Okay. Sorry, guys.
Oh, you're good. That helped me to understand what I do. Fix my mistake.
What's that?
Help me fix my mistake, so that was good.
All right, so which problem do you guys want to go over now?
I say we try to figure out the number 4. Figure out that magnitude of the vector and the direction and the component form.
Okay.
So it seems
On
like
the activity or on
most of
the
us don't know. Preparation activity. We'll do that one, and then we can go to extension problems, whatever.
sounds good.
What is Cartesian?
That's just the XY coordinate system.
Okay. So we're doing number 4?
Yeah.
So we just start off by going like the number of degrees. So just start off like going around 312 degrees and then going out 7.2. Is that how it works? Or
We're trying to find like the point, I guess you can say, or just like, because you know how like we're given like a coordinate and then we can use that coordinate to find the magnitude or to find the direction and everything. So we're just trying to find that original coordinate to help us out. So everyone knows that the equation, it's like V equals magnitude, sine or cosine, depending on which coordinate you're finding, and then the angle, right? So considering that we know both the magnitude and the angle, to find A, we use cosine, and then to find B, we use sine. So then it would be 7.2 cosine 312, and we get A.
so how do you know it's cosine though, like in this situation?
Well, because so we're finding, so A goes to cosine and B goes to sine.
Okay.
So if you're trying to find A, you use cosine or just whatever. And if you're wanting to find B or use B, make sure you use sign. It's just like kind of like how in the triangles, C went to like angle Y, B went to angle B, and A went to angle A,
Right.
sign, and all that. So it's just kind of like that same thought.
Okay.
Okay, so you go. So instead of using like 312, we could use, if we're drawing like a triangle, we shoot 360 minus 312, which would be like 48 degrees. And then draw your triangle. Right?
Whoa. Drawing a triangle? I missed something.
So
I wasn't listening.
I'm just plotting it on the XY system. And so
Number 4, do we have to plot it?
You don't have to, but I'm just that's how I'm trying to solve it. So I drew a line at 312 degrees.
Mm-hmm.
And then using the positive x-axis, I made a triangle with using the angle from the vector and the x-axis. It's like a 48-degree angle. And I plotted the line A and the line B. So I'm getting this here. See that?
Yeah. Yeah, that looks right to me.
Okay.
The simplest way to solve it is, since it gives you the angle and the vector, you can just multiply the vector by you can go 7.2 times the cosine of 312, and that's your x, and then 7.2 times the sine of 312, and that's your y.
Do you want this?
No.
It's so good.
Yeah, I think so. But if needs be, like if you need to draw a triangle, that would work. I think the simplest way is just doing that. Does that work for everybody?
Mm-hmm.
I think that's the simplest way to do it.
Just over here, I don't want to be seen.
Here, I can. Are there any others that you guys wanted to work on? So did I explain that well enough? Did everybody get that?
Yeah, I'm just trying to understand like how to write the answer, I guess. Okay, sounds pretty stupid, but I don't know how to write the answer.
So the answer is just like a coordinate. So like it looks like,
An XY coordinate, yeah.
yeah, it just looks like that.
Okay. So it's supposed to be like the parentheses or like the.
No, because
I think they have they have the angles, but
Okay, that's what I was trying to do. Okay, cool.
yeah, that's not stupid at all.
Sweet.
Okay. Did we do number 3?
No, we didn't go through that one, I don't think.
That one has the typo that me and Kaylin found out.
Oh, when you guys were like, got 225 or whatever?
Yeah. We'll do 55 because the answer is 225.
Oh,
So, didn't understand that question, Curtis, or do you want me to explain?
no, I think I got that. I took a lot of notes while I was doing the homework, so just about like what kind of formulas to use and stuff.
Right. Yeah, so it's just I think it's a typo.
Okay.
Should we do the extension problems?
Yeah, let's do 'em.
Given 2 vectors, how would you find the resultant vector? Draw 2 vectors and the resultant vector. Okay. Let's do like vector like 3, 1 and like 2, 2. I don't know.
You said 2.
You could do that. I don't know.
Yeah.
So I don't know if this is right. So if it was 3, 1 and 2, 2, the resultant vector would be 5, 3.
Yep. What I got?
Because the resultant vector is just like if the one vector is u and the other is v, then the resultant is just u plus v.
Mhm.
Can y'all hear me?
We can see you, Caleb.
Looks like he's trying to talk to us.
Hmm.
Nice haircut. Is that the answer you got, Callum? I don't think I don't know. You guys need to go over anything?
I got a question on one of the. Let me find it. I think it was on the preparation. Oh, so it was the last one. It was 7, but it was the very last problem on the preparation is like -3 and 6 was the coordinate. But I wasn't able to figure out that one.
-3 and 6.
Yeah. It says convert to either Cartesian or polar. I wasn't sure how to get this one. We just have the 2 points.
-3 and 1, 2. So the radius would be square root of 45, which would be 3√5. So would it be 3 root 5, or if you wanted to figure that out, and then whatever angle it is. You started at 3 root 5 and moved it. You need to know the angle,
Okay.
I think. I'm just thinking, so if it's 3 over and 6 up, the radius is the hypotenuse. So 3 squared plus 6 squared, the square root of that. 9 plus 36, 45. So square root of 45, that's the radius. And if you start at 3 root 5 on the x-axis, wherever that is, that's your radius. Then how far do you need to go to get to that point? Negative 3, 6. So you need the angle, that angle.
Okay.
I think you can find it though. It would be, that's a right angle.
It's just saying like how much or how big does the angle need to be to get from negative 3 to 6? Or
No, I think so. Like, if you're, say this here, yeah. Say this point right here. Let's see. Where's my pencil? This point right here is 3 root 5. 3 times the root of 5. That's your radius. And what is this angle to get it to this point? See what I mean?
The 3 6. Yeah.
What?
That's like that point's the 3 6, isn't it? Negative 3 6. Yeah.
Yeah. So if it's a right triangle and we have all the sides, then it would just be the tangent of 6 over 3, or the what's it called? The inverse tangent of 6 over 3.
okay.
Right?
I think so. You're using the inverse to get the angle, right? That's why.
Yeah, because so like whatever angle that is, just this angle right here from this right here, this angle, what we started with. That's going to be the tangent of this angle is 6 over 3 opposite over adjacent. Oh, shoot. Not even showing it. So the tangent of this angle is opposite over adjacent, and then it would just be 180 minus that angle.
Yes.
That's how to go. Okay. Gotcha.
So the inverse tangent of 2 is 3 point blah blah. So 116 degrees. And then I don't know how to write it past there because I didn't learn what polar and Cartesian is. I'm just going off what I learned today. 3 root 5. Oh, that's it. 3 root 5 and then 116.57 degrees.
Okay.
You get how I did that?
Yeah, it just drew the triangle on the coordinate they gave us, and then you said you used arc tangent, right? Or inverse tangent. Yeah.
Yeah,
Okay.
so we knew that it was 6 tall and 3 wide. We knew this was 3 root 5. Then we needed this angle right here.
Okay.
And then 180 minus that angle. And that's the angle we get. So if we start at 3 root 5, well, I guess for you guys to be over here because it's opposite on the computer. So if you start at 3 root 5, we need to go 116 degrees
Right.
in that radius, and you get that coordinate.
Gotcha.
I don't know. Okay. I have to go to work. You guys can. Sorry, I came late and I'm leaving early.
That's cool. I don't have any questions, so
Yeah, I'm good.
All right.
cool. Caleb, you got anything?
Oh, you can't hear us.
No. Sorry.
I think he said he was good though.
Okay. Awesome. I think he's recording it, right?
What?
No, he's recording it, right?
Yeah.
Okay, cool. So I can exit out.
Yep. Bye, guys.